In last class we discussed about the depletion type MOSFET. In that we discussed the construction of n-channel depletion type MOSFET and its operation. Then after we discussed the drain characteristics and transfer characteristics of depletion type MOSFET. Now we'll discuss about enhancement MOSFET. So the main difference between the depletion MOSFET and enhancement MOSFET is the presence of channel. In depletion MOSFET, channel is present, which is lightly doped n-type material is diffused into the p-type substrate. It is acts as a channel. Coming to the enhancement MOSFET, we don't have any physical channel. So this is the only difference between the depletion and enhancement MOSFETs. So again, enhancement MOSFETs also two types: n-channel enhancement MOSFET, p-channel enhancement MOSFET. We'll discuss about the construction of n-channel enhancement MOSFET. So we said the depletion MOSFET is operates in the enhancement mode and depletion mode, but this type of enhancement MOSFET is always operates in enhancement mode only, and it does not have any depletion mode. Yes. So this n-channel enhancement MOSFET is fabricated on lightly doped p-type material is known as substrate or body of MOSFET. It is similar to all the FETs. Two heavily doped N regions are created on p-type substrate by using impurity diffusion method. These N plus regions act as source and drain. A thin layer of insulator silicon dioxide is present to isolate the platform from between drain and source, but now it is simply separated from section of p-type material. So you can observe the light grey color indicates the silicon dioxide or insulation material in the diagram. Yes. Does not have any physical channel between the source and drain regions, but channel can be formed electrically by applying the appropriate voltage at gate terminal. So to get the proper operation of MOSFET, again we need to apply the two types of voltage. One is VGS, another one is VDS. So this VGS is applied to create the channel between the drain and source. So in enhancement MOSFET, here we don't have any channel between the source and drain. So to create the channel between the source and drain, so VGS is very important. Yes. So VGS is used to apply the used to create the channel between the source and drain, and it controls the connectivity of the channel. So this VGS value is generally positive for the N-channel MOSFETs, N-channel enhancement MOSFETs, and negative for the P-channel enhancement MOSFET. We know that VDS, drain to source voltage, is always applied to drift the major charges from the source to drain through the channel. Due to that, you will get the IDS value. Yes. So VDS is always positive for any N-type FETs, that may be JFET or depletion MOSFET or enhancement MOSFET, and VDS is always negative for the P-type material, P-type device that are JFET, enhancement or depletion MOSFET. So how we are creating the channel between the source and drain by applying the gate to source voltage VDS value. We'll see. So when you are applying the more positive gate voltage to the gate terminal, that gate is made up of metal, so the more positive charge is accumulated on the metal. Due to the more positive charge on metal, the silicon dioxide is polarized. So silicon dioxide is a dielectric material or insulation material, So it does not have the conduction, but it has the electrical charge, that means negative charge and positive charge. So due to the more positive charge on gate or metal gate, then what happens? The polarization of silicon dioxide becomes more stronger. What is polarization? Polarization is nothing but the charge is separated. The negative charge and the positive charge is separated in the silicon dioxide material. Yes. So more positive charge on gate attracts the negative charge in the silicon dioxide layer and repels the positive charge in the silicon dioxide layer. So due to the more positive charge on gate, negative charge moves upwards in the silicon dioxide layer and positive charge moves downwards in the silicon dioxide layer. So more positive charge moves downwards in the silicon dioxide layer, that positive charge will attract the minority carriers in the p-type substrate. What could be the p-type substrate minority carriers? That are electrons. So due to the higher positive voltage on metal, silicon dioxide layer is also strongly polarized. So that means more positive charge in the silicon dioxide moving downwards, that more positive charge in the silicon dioxide will attract the electrons in the p-type substrate. Yes. So the electrons are accumulated below the silicon dioxide layer. These accumulated electrons or forms a layer, it is called inversion layer. This inversion layer is acts as channel. So when gate voltage is continuously increased, the density of free electrons in the inversion layer keeps increasing, whereas keep on increasing, then the concentration of electrons in the inversion layer increases. That means that inversion layer is acts as a channel, so the conductivity of the channel increases. Clear? So increasing more and more gate voltage at some particular value of gate voltage, the concentration of electrons in the inversion layer is almost equals to the concentration of holes in the p-type substrate. It is called threshold voltage. Clear? So now we created the channel by applying the positive gate voltage. Yes. Now we discuss about the operation of enhancement MOSFET. In this, we know VDS is used to drift the carriers from the source to drain, and VGS is used to create the channel. So now we are considering the VDS to be constant, and we are varying the VGS from 0 to positive values. So if VGS equals to 0, then what happens? So we cannot create the channel. So channel cannot, there is no channel, then there is no current. Yes. So IDS equals to 0. If VGS is small and positive value, then what happens? Gate material gets positively charged. It causes the polarization of silicon dioxide. So the positive charge of silicon dioxide will repel the holes from p-type substrate, and a depletion region forms below the silicon dioxide. If we are increasing further VGS value, then what happens? Positive charge silicon dioxide becomes more strong enough to attract the magnetic electrons of p-type substrate. So it is already discussed the same thing. Yes. So the magnetic carriers in the p-type substrate will form the below the silicon dioxide layer. It acts as the inversion layer. It is also called as channel, n-type channel. Yes. So the value of VGS increases further. What happens? The concentration of electrons increases in the inversion layer or channel. So for a particular value of VGS, the concentration of electrons in the channel becomes equal to the concentration of holes in the p-type substrate. That is called threshold voltage. So then electrons start flowing from the source to drain. Yes. So we can say threshold voltage is nothing but at which gate voltage the conduction starts in the enhancement MOSFET is called threshold voltage. Yes. So increasing VGS further, what happens? So after the threshold voltage, when you are increasing more gate voltage, what happens? The concentration of electrons will increase in the channel. Thus, the conductivity of channel will be enhances or increases. So then drain current also keeps increases. Then this device is called enhancement MOSFET. So we can say from this, the gate voltage must be positive to create the channel in the N channel enhancement MOSFET. So VT is positive in the enhancement MOSFET, N channel enhancement MOSFET. VT is negative for the P channel enhancement MOSFET. So before the threshold voltage, that ideas is very small or negligible value with respect to the VGS. After the threshold voltage, it starts or the conductivity of the channel enhances or increases, the drain current is also increases. So you can observe in the transfer characteristics of the N channel enhancement MOSFET. So in this, we draw between the VGS versus IDS, where VDS is constant. Clear? Second case, till now we consider the VDS is constant, VGS is varying from 0 to positive values. Let we consider VGS to be constant and it must be more than the threshold voltage. Why? Because when it is more than the threshold voltage, then only we can form the channel. So now we are varying the VDS from 0 to positive values. So for MOSFET to conduct, VGS should be kept constant at a value greater than VT. Yes. So here we are considering the net gate voltage. What we can write? Minimum threshold voltage is nothing but to start the conduction or to form the channel between the source and drain. Yes. So net gate voltage we can write it as a VGS minus VT. So it is also called as net gate voltage or effective gate voltage or overdrive voltage. Yes. So when overdrive voltage is less than 0, that means VGS minus VT value is less than 0, then we can say VGS is less than VT, then channel we cannot form, then current is 0. If VDS is 0, then electrons cannot drift from the source to drain. If I am varying from 0 to positive values. Again, VDS equals 0, so the drain cannot drift to the electrons from source to drain. So it is 0. Now, VDS is increased or positive and very small values, it is like 0.1, 0.2, 0.3 volts. Then drain current increases linearly with VDS because channel resistance RDS is constant. From that we can write IDS equals to VDS by RDS. It is RDS is the channel resistance and it is constant. Yes. And if VDS is further increased, then net gate voltage or overdrive voltage BOV. When we are increasing the VDS value, then what happens? The net gate voltage with respect to drain, gate to drain VGD value is equals to the overdrive voltage minus VDS. Yes, it starts decreasing. So due to this, the gate region will not be able to attract the more number of electrons into the channel at drain side. Yes, so when you are increasing the more VDS value, then gate to drain voltage decreases. Why? Because gate to drain voltage is equals to overdrive voltage minus VDS value. So when VDS value increases, then what happens? Gate to drain voltage decreases. So when gate to drain voltage decreases, then what happens? So at drain side, it cannot attract the more number of electrons into the channel. So due to this reason, channel depth decreases on drain side That means channel becomes tapered shape. You can observe the diagram here. Yes. So tapered shape means so it is not directly connected to the drain. It is disconnecting from the drain. Yes. If VDS equals to VOV equals to VS minus VT. Yes. If VDS equals to overall voltage, it is nothing but VS minus VT. Then net gate voltage with respect to drain VGD becomes 0. Why? Because VDS equals to VOV, so VGD equals to VOV minus VDS, so then VGD becomes 0. Channel gets pinched off, so channel cannot directly connect to the drain, it is disconnected, that means pinched off. Yes, it is pinched off on drain end. If you are increasing more VDS value more than overdrive voltage, that means VDS is greater than VS minus VD, then pinch off point moves away from the drain by some small distance delta L, we consider it as. So what are the excess voltage applied at VDS, that means VDS minus VOV is nothing but excess voltage, will drop in the delta L distance. Yes, due to this very strong electric field develops in the delta L distance. So now drain side becomes the reverse bias. So this reverse bias it forms the depletion region. So in this depletion region we are having the immovable charges. These immovable charge carriers will develop the very high electric field. Yes. So we can write electric field equals to voltage per distance. So whatever the excess voltage it is nothing but VDS minus VOV. So the pinch off occurs delta L distance from the drain, it is delta L. So VDS minus VOV delta L. If delta L is a very small value, then the electric field intensity becomes very strong. Yes. So when electrons are entering into the high electric field high electric field region, then what happens? So electrons are coming from source to drain. In that duration, what happens? So channel is pinched off at the delta L distance. So when electrons are moving from the source to drain, when these are entering into the high electric field, these electrons velocity becomes constant or saturated. So it is from electron velocity saturation. Yes, hence drain current becomes IDS becomes constant. So we can observe this drain characteristics of MOSFET. So for every VS value, this IDS value is constant after the pinch off points. Yes. So now we can consider into two parts. So the pinch off points are connected. So it indicates the locus of pinch off points. So it is always indicates the parabola. So it divides into two parts. One is ohmic region, another one is saturation region. It is similar to our JFET. Yes. Divided into two regions. One is triode region or saturation region. Triode region is also called as linear region or ohmic region. In this region, what happens? The drain current ID or IDS is linearly varying with the VDS value. So MOSFET is behaving as a resistor. Yes, in saturation region or pinch off region, so your drain current remains constant with respect to the VDS. Therefore, MOSFET is equivalent to the constant current source with respect to VDS. By increasing the VDS value, current is always constant. So we can say in saturation region, it is a constant current source with respect to the VDS. But in drain current increases with VDS value. So we draw the drain characteristics for different VGS values. Yes. So that drain current is increases with the different values of VGS. Therefore, MOSFET is a voltage controlled current source. Yes. So you can say it is a voltage controlled current source with respect to the VGS in the saturation region or pinch off region. And it is also used as a amplifier in the saturation region. It is already discussed in the JFET. So condition for the saturation region in the N channel MOSFET is VDS is greater than or equals to VGS minus VT. So The same thing for p channel MOSFET. VSD is greater than or equals to VSG minus mod VT. So these are the different symbols of enhancement MOSFET, N channel and P channel. So this enhancement MOSFET or MOSFET is also called as MOS transistor. So N channel MOSFET sometimes called as NMOS, P channel MOSFET is called PMOS. So these are the different symbols for the enhancement N channel and P channel MOSFETs. Yes. So don't confuse here. Please look into carefully. So here the direction of the current indicates the drain current here. So in first here it indicates the substrate to gate voltage. So here we are keeping the gap. It is not a straight line. It is we are considering it a gap. So why? Because here there is no channel. Yes. Thank you.